assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Alright, so for this problem, there is a pendulum formed by pivoting a long, thin rod on a specific point in the rod. And there's experiments done to see how the period is measured as a function of the distance x between the pivot point and the rod's center. We're given that the rod's length is 2.20 meters and its mass is 22.1 grams. And we're trying to figure out first, what is the minimum period? Well, according to the parallel axis theorem, we can find the rotational inertia when it's pivoted at distance d from the center, or in this case x from the center, as inertia equals 1/12 the mass times L squared plus the mass times the distance squared. We also have the equation that the period equals 2 pi times the square root of inertia divided by mass times gravity times our distance. So now we can go ahead and substitute in this term for our I. So we end up with t equals 2 pi times the square root of 1/12 ml squared plus mx squared divided by mgx. And simplifying that, we end up with 2 pi divided by the square root of L squared plus 12x squared divided by 12gx. Since we want the minimum, we want our t minimum, we are going to do the derivation of this. So we're going to get our dt over dx as a function of distance to equal 0, which means that x equals L divided by the square root of 12. We can now take this and plug it in up here as well. So that new equation, our t minimum, is going to be 2 pi times the square root of L squared plus 12 times L squared divided by 12 divided by 12 times gravity times L divided by the square root of 12. And we have a length that we were given at the very beginning, that L equals 2.20 meters. So we can go ahead and plug that in as well. So our final, once we have everything plugged in, we have our T minimum equals 2 pi times the square root of 2.20 squared plus 12 times 2.20 squared divided by 12, all divided by 12, times 9.8 times 2.20 divided by the square root of 12. And that ends up giving us that T minimum equals 2.26 seconds. And since x was chosen to minimize the pyramid, then as our length increases, the period also will end up increasing. If instead the mass changes rather than L, and L does not increase or decrease, then the period itself will not end up changing, because as we can see from here, when we were back up here towards the top, because our mass ended up getting divided out, if our mass changes, it's not going to have an overall effect on the period.